In this video, I'm going to be describing a method for embedding a secret message inside of the blue layer of a PNG image file. This method allows a secret message to be spread across two images. Eventually, these two images can be brought together. Some sort of arithmetic is performed on them, and the original message is revealed. This method is accessible to anyone who has a regular image editor on their computer and doesn't require any special software. So the first thing I'm going to do is I'm going to prepare a public image from a picture of Milford Sound, New Zealand, and I'm just going to be doing some cropping to this image so that it'll look better for our tutorial here. Okay, now I have an 800 by 800. I'm going to copy the entire image, paste it as a layer. You'll have to forgive me for using an image editor from the 1990s. All of the operations I'm going to be performing on these images should be easily replicated in any kind of modern image editor such as Adobe Photoshop or GIMP. So what I want to do now is just add some noise to this layer. Noise. Do some blending. That's 4. See how that looks. All right. Merge these layers. All right, what I've done now is prepared a public image by adding a little bit of noise into it. PNG. Later on, we will see why I added the noise in. So the first thing I'm going to do is to create our first step for creating the second image, what's called the reference image or the private image, is to break this into color components. So split this to RGB. Don't need that anymore. So we have a red, green, and blue set of layers here. And then I'm just going to duplicate the red and green on top of themselves. So I'm going to copy, paste this new layer. Same with the green. On the blue channel, I'm actually going to duplicate it into a different image. So copy. This is a duplicate of the blue. Over here. Add 100% noise to that layer. This image on this layer. 100% noise. And then here, I'm just going to make a a text mask. Load this up. Line in here. Check on that. It's a little bit too big. 36. The text I just created was actually created as a selection. So this is the line. I'm pressing delete. Line is gone. Background, we don't need this layer anymore. Okay, I'm just copying the selection inside of the letters. I'll paste as a new layer. And this old program from the 90s does not put it in the same spot. So do some lining up with the pixels here. There we go. There it goes. Okay, good. So we have now, well, let me turn off the selection. There's two layers in this image now. There's the background, which just looks like what we made. And then on top of it is a duplicate of the same pixel colors inside of the shape of our secret message. We're going to add 100% noise to the background. Good. But on the layer holding the secret message, we will only add 54% noise. Now the way this works is, this is a speckling operation. So the number 54 here actually represents the probability that a pixel receives a mutation. We can see, for example, the speckling operation with this noise is the density of pixels that are mutated. Without the noise, we can see, we can still make out the lettering here. This is 100% noise in the background and none on the lettering. Let's add 54% noise. Okay, good. The lettering is barely visible. Just merge these layers. All right. Now what I'm doing now is I'm copying this entire image that I just flattened. And I'm going to paste it as a layer on our blue channel here. Here. Watch. New layer. Don't need that anymore. And then I'll just use normal blending mode. Down it. Whoa, wrong image. Let's just start on the red here. Let's start on the red. All right. Normal blending mode. I'm just going to go down to 3 here. There we go. Same for the green. Normal blending. 3. Three of 100. Same for the blue. Normal blending mode 3. There. And then I'll just merge all the layers for all these. Merge the blue. Merge the green. Merge the red. Oh, it's already merged. Oh, no, there it is. Merge the red. Now, 3 flat channels. Combine them back. Red to red, green to green, blue to blue, blah, blah, blah. Okay. There's our result. Don't need these anymore. No, no, no. This is ready to be saved. This is the reference image. We can also call it the private image. Let's see here. Let's see. Ping. Okay. Put a little law. Save. Now, let's see here. Okay, here's the PNG. That's our public image next to the private or reference image. You can look at these on a pixel by pixel basis, particularly in the clouds. You will see a little bit of noise. That's okay though, because the noise also exists in the public image as well. For all intents, these two images are visually identical. So, final step would be uploading these images somewhere, preferably to 2 different places on the internet. The public image is okay to give to anyone. The private image is obviously containing some sort of secret message down here in the grass. Nothing there visually. Looks the same as the public image. So, to reveal, after we've downloaded both copies of these things, to reveal the message again, we need to perform arithmetic on it. So what we're going to do is, in this particular application, it's called arithmetic. Okay, let's just do public image, private. The function we're going to do is difference, not subtract, but difference. And then the channel, we could do all channels, but we're not. We're going to do the blue channel only. Okay. This gives us a black image in Photoshop or GIMP. You'll have layers instead. You'll need to flatten them. And then we'll do an equalization of the histogram. Now, it looks like we have a black image here, but in reality, there's some stuff going on down here on the histogram, near 0. That's what we want. We want to see what's going on down here. The way we're going to do that is by equalizing the histogram. And immediately we'll see some stuff going on down here. This is a little bit difficult to see when you're close to the image. You might want to stand back in the room. The other thing you can do is add some blur in. That makes it a little bit easier to read. You can see www.ecrypt.eu.org, blah, blah, blah. And some people have suggested that maybe this particular pattern could be retrieved merely by looking at just the reference image in isolation. So a friend of mine suggested that these particular letters could be revealed through some method just operating on the reference image, such as a fast Fourier transform. I'm going to disagree with that method, and my disagreement is if I had placed these letters up here in the clouds, there'd simply be no way to visually make them out. Also, you may notice that these differences between the dark and the light images are also replicated in other parts of the image, such as the grass over the water here. So for these reasons, I think the secret message here probably isn't retrievable in any kind of automatic method by just looking at the reference image. So that's my tutorial. Thanks for watching.